All right, today we are going to be starting chapter 5, and it is on algebraic expressions. And this chapter is very much about vocabulary and learning what algebra is, as much as it is about evaluating expressions. You're going to find that in this chapter, a lot of times we don't get a number answer. So keep that in mind as we go through this chapter, that it's not just about getting an answer, but it's about learning the vocabulary and learning about algebra and getting that algebra background. Okay, take a look at page 350 here. The branch of mathematics that involves expressions with variables is called algebra. So there's that ugly word that we're all afraid of. In algebra, the multiplication sign is often omitted. Take a look at these terms. These are called terms. Where there's 6 right next to the D, that means multiply, 9 right next to the S, and the S right next to the T. Those are all multiplying. M right next to N means multiply. And even A to the third power means to take A times A times A. It's just a quicker way to write that. So the numerical factor of a multiplication expression that contains a variable is called a coefficient. You need to get used to this definition, because it is a mouthful, but it keeps coming up throughout this chapter and the next chapter. The numerical factor, the number, factor means to multiply, of a multiplication expression that contains a variable, another vocabulary word, so we could say contains a letter, is called a coefficient. So if you go back up here to this problem, 6 is the coefficient. You come to this one, 9 is the coefficient. It is the number that is being multiplied times the letter. There is a coefficient here, you just don't see it because it's not necessary. 1 is the coefficient. And the same thing here. 1 is the coefficient. In an expression like y divided by 2, you would say that 1/2 is the coefficient because 1/2 can be multiplied by 2 by y is the same as y divided by 2. 1/2 times y is the same as y divided by 2. So we would say 1/2 is the coefficient. Now that brings us to our examples finally. And actually back in chapter 3, we evaluated problems similar to these, using order of operations and plugging in numbers for letters. So this should look very familiar. So page 350, example 1, we are given n equals -4, and the expression 2 times n plus 3, and then we would take 2, and we would plug in -4 for n, plus 3. Different signs mean we subtract and take the sign of the bigger looking number, so we end up with -1. We need to leave it in parentheses so that we can continue to show multiplication, and 2 times -1 is -2. Different signs, negative. Look at example number 2, which says 8w minus 2v, where w equals 5 and v equals 3. So 8 times 5 minus 2 times 3. You will want to take 8 times 5 and get 40. -2 times 3 and get -6. Notice how I attach that negative sign to the 2? You need to get in the habit of doing that, because if there were a negative inside of this parenthesis, we would want to have a positive here. So make sure you're attaching this sign right here, to its number. 40 minus 6 is 34. And then example 3, 4y to the third power plus 2, where y is equal to 3. We will do 4 multiplication, 3 close parentheses to the third power plus 2. Order of operations says I need to take exponents first, since there is nothing to be done inside of these parentheses. So I will do 4 times 3 times 3 times 3, which is 27, plus 2. Second, I need to do multiplication. So I will multiply 4 times 27, and that gives me, might have to do that off to the side, right? 28, carry the 2. 2 times 4 is 8, plus 2 is 10, so I get 108, plus 2, which is 110. Let's go ahead and go over and take a look at example number 4. These letter problems you will do after the video. Example number 4 says athletic trainers use formulas like 3 times 220 minus A divided by 5, where A is a person's age, to find their minimum training heart rate. Find Latrina's minimum training heart rate if she is 15 years old. So formulas are a form of algebraic expressions. This algebraic expression or formula is 3 times 220 minus the age of a person divided by 5. So that's the minimum heart rate. And in this case, she is 15 years old. So we're going to plug that in. 3 times 220 minus 15 divided by 5. That would be 3 times 205 divided by 5. And then we will multiply. Actually, we could also reduce if we wanted to. 205 divided by 5. It's totally up to you which you do. I'm going to go ahead and multiply because I think that's easier for me to do in my head. I get 615 when I multiply 3 times 205 divided by 5. Now I'm going to have to do a division problem. I'm going to put the top number, 615, inside the bracket. I'm going to put 5 outside the bracket. 5 goes into 6 one time. I subtract, I get 1 left over. I bring down my 1. 5 goes into 11 2 times. I get 10. I subtract, I get 1 again. This time I'm bringing down my 5. And 5 goes into 15 3 times. And it goes in evenly because 3 times 5 is 15. So 123 beats per minute would be the heart rate for her target minimum heart rate. That leaves you, G, to do on your own after the video. Let's go ahead and take a look at the final example, example number 5. Before we do that, we have another vocabulary word that pops up that says define a variable. To translate a verbal phrase into an algebraic expression, the first step is to define a variable. When you define a variable, you choose a variable to represent an unknown quantity. As we go through word problems in this chapter and in the next, we will be doing this. We will be defining the variable. We will be asking ourselves, what are we trying to find? What is that missing number that we're going to use a variable to represent? In this problem, example number 5, it says, Marissa wants to buy a DVD player that costs $150. That is a fact. DVD player costs $150. She already saved $25. There is another fact. And plans to save an additional $10 each week. $10 each week. Plans to save $10 each week. That's not just $10, that's $10 every week. So it's important that we understand that. It says write an expression that represents the total amount of money Marissa has saved after any number of weeks. Any number of weeks. We're missing some information there. We don't know how many weeks she has saved money or will save money. So this is where we're going to define a variable. We would make W stand for the number of weeks. I like to use the hashtag. Back before it was a hashtag, it was a pound sign or a number sign. And so I like to use that to represent number. And so W equals number of weeks. This naming the variable, W equals number of weeks, is what we call defining a variable. Now we can start putting together our expression. It says that she's going to save $10 each week. What would we do with W and the 10 to show how much she would save after 1 week, after 2 weeks, after 5 weeks, after 10 weeks? Well, we would multiply it. We would take our $10 per week and multiply it times the number of weeks. We know that she already has saved $25. So in addition to what she's going to save each week, we know that she's already saved $25. This actually has a name called a constant. It is a one-time thing. And so we call that a constant, and we're going to add that in. Constants are either added or subtracted, and we'll keep saying that over and over again as well. Now, it doesn't say anything about making this into an equation. The total cost of the DVD player, that's not going to come into play in this problem. We just want to know how much money she has saved after 1 week or 2 weeks or 3 weeks or 4 weeks. Okay, so I believe when you go to the next letter problem, you are actually going to take this. Oh, it's example number 6. Okay. In example number 6, we're going to find out how much money she would have after 11 weeks. So in example 6, we're going to take the expression we just wrote, which was 10W plus 25, and we're going to plug in 11 for the number of weeks. So that would be 10 times 11 plus 25. You do multiplication first and get 110 plus 25. And that would equal $135. And so the question is, will she have enough money after 11 weeks? And no, she does not have enough. She needs $15 more. All right. Now that you are done with the video and copying down all the examples, you need to go ahead and complete the letter problems on page 350 through 352.